Welcome to podcast episode 3.
Yeah, 3.
Episode 3, our Valentine's Day special. This episode of the podcast is pre-recorded due to the fact that this Wednesday falls on a holiday. But nonetheless, we're here and we're gonna keep on coding. Yeah. So by the time you're watching this, happy Valentine's Day. And today we're gonna be going over classes and loops. So let's start with loops and move on to classes. Let's get right to it. I'm Sergio.
I'm Isaac. And I'm Christian.
And this is the CSS podcast.
Today we have the absence. So.
Oh yes, today unfortunately we're not being joined by Amanda, but she hopefully will be here for a future podcast. She's with us in spirit.
She's right here. She's here. She's with us in spirit, and also she's about a mile away. So like,
yeah, I mean,
where is she?
She lives like right here.
She lives like 2 blocks away.
She lives in front of the medical building. So she's here a mile away.
Yeah. So Isaac,
what's up?
Since you kind of started CS computer science at the same time as this podcast started, what have you found to be most helpful so far?
Most helpful have definitely been I would have to say that the most helpful ones commands for me have been the math ones. Those have really helped me out, especially since I work in a lab. I've just been trying to make things, little small programs that can help me out in the lab. Yes. But also manipulators help out a lot as well. IO and them found that very useful.
The IO and yes. Have you covered any of the topics in class that we've covered so far in the podcast?
Yeah, I've pretty much everything you guys have covered. I've covered it in class so far, except I've always learned it here first before learning it in class.
Hey.
What do you know about loops?
Loops, loops? No, today, that's about all I don't know. We're covering that next class. Today we covered if statements and else statements. So
that's a loop, that's a type of loop.
Well,
I thought a loop was a while.
It's a conditional.
It's a conditional loop. Which I'll explain later.
I believe there's someone at the door.
Today was a really fun because I made a mean random number generator. So basically, it would generate a random number, and then if you guessed it, and then you would guess the number that it was. So if you guessed below, it would say sucks to suck. If you guessed above, it would say LOL, wrong number boy. And then if you guessed it right, it asks if you wanted to cook it. So you can never win with this program.
So I mean, it's good. That means you've actually been using what we've been going over in the podcast, which is great. Actually, let me.
Yeah, I'll show everyone I could.
No, roast me. I'm not ready.
We have it here. So yeah, you used the if loops. We're using the. Let me show everyone real quick. The picture real quick of the code.
Yeah, let me turn it because it's hard to see.
Everything else zooms in except for the picture. Hold on.
Maybe you zoom out. Okay, yeah. Okay, now it's just.
There you go. All right, so let's take a look here at your code.
I'm kidding.
So okay, let's see. You used something we didn't go over, but you got right was a random number generator.
Yeah, you have to seed it, right?
Yes.
S-brand, yeah.
You include all your libraries. You set up your function very nicely. I like how your entire program fits in one page. You don't have to scroll down to see it. Great, but one thing I do notice that when you sent us this program, or showed us this program, is that you had to rerun it every time.
Every time.
You wanted to make a different guess, right?
Yeah, that was kind of annoying. Always having to click F5.
Yeah, so
You make a function for that.
we can make that with a loop.
You can actually wait a minute. I don't have to close it and then hit F5 again to redo it.
You can
I can just
keep
do
going.
the same command.
You can set up
You can stop it at some
you
point.
can set up a loop so that you don't have to stop the program and start it again.
So if I guess wrong, it'll give me another chance.
Exactly.
Yes.
Okay.
And you can program that, and that's actually what we're going to be going over today.
That's cool.
So let's switch over to our Visual Studio, and as you can see, we already have our Hello World set up. So I'm gonna copy your code.
I actually have my code.
Do you have your code?
Yeah, saved in USB.
You should totally send it to us.
Let me go get it.
All
I'm
right,
gonna
cool.
step out of frame real quick.
Meanwhile, I can get a beer.
Yeah, I'm the same thing too.
Where's the plane? I have free ice cream still.
Wow. You want keys? Oh. Wait, hold on. Wait. You found I just kind of give it to you instead?
What?
So mine like it. Because
Okay.
I really like
Try. I mean, I'm pretty sure Miller. Oh,
the
awesome.
smell kind of throws me off already.
Miller is probably better than Keystone.
I can deal with it. Yeah. Okay, keep going.
Files. Komsky. Mean Machine.
Komsky?
Call it Komsky.
Okay.
You know,
Komsky.
You almost just hate me because I call it the
you
wrong
call
thing.
everything different. Like for us, it's comp sci.
They call it Komsky. How would I give my chemistry?
Alright, cool.
Chem. I want to give it to him.
Alright, awesome.
Alright.
So let's see, which one was the useless one? This one's remove that one.
Trash.
Delete that. Okay. We should not keep the same song on repeat. Alright, so let's see.
So, and I just, so I wouldn't,
It's 6!
so I wouldn't punch my computer. I cheated.
For debugging purposes.
I made it tell me.
That's what we say whenever we cheat in coding. We say it's for debugging
For
purposes.
debugging purposes. Yeah.
Okay, so
Frank Sinatra.
that's good. Let me just smidge.
Oh wait, no, I got it.
Awesome.
Wait.
Just making sure the second monitor wasn't showing up. Okay, so right here you run the program, you guess a number, and then it's over. But if we choose it wrong, right, like 5,
It's just like,
then we can't. We have to rerun it again.
yeah.
So let's go over the different types of loops we have so far. So I'm gonna comment out your code.
Okay.
So let's. Okay, so in case you're new to C++ as well, you can comment out a large section of code by using this to starter and this to end it. So wherever you end it, it'll be a comment. So we'll put it here. Now it interprets this entire block as a comment, and I can just. Oh. There you go. Okay, so we have a couple different types of loops. First, you want to figure out what kind of behavior you want your program to have. Do you want it to loop endlessly until you get it right? Do you want it to loop?
Like give me three chances.
Yeah. Do you want to give 3 chances? Do you want to do it up until you get something correct? Any sort of thing. So, let me show you the different kinds of loops. We have the for loop, and these loops will haunt you for the rest of your life. You have the while loop up until you learn recursion. Then that replaces the loops. For, while, and then do.
So,
And then,
there's for loop, while loop, and do loop.
Yeah, and then the do loop can be combined with a while.
Should we consider the case switch a loop?
Well, the case we already went over it last time, and it works just like the if-else statement. It just has a different layout to it. So the reason these are loops is because it'll keep on going until
Something
tells it to stop. Yeah. So if you want to make an infinite loop, for example, well, let's just go down in order. For example, you have this for loop, right? And the most basic or the most standard way to use it is you put int I equals 0, I is less than some number, right? And then I plus plus, right? So what this actually,
with the plus plus?
yeah. So this would actually, what this is doing is first starting off a counter, right? So you initialize a variable, and this is what's going to be incrementing every time the loop goes around, right? So if you want your program to do things a finite number of times, this is the loop you're going to want to go for. And then you have the condition right here. So whatever if this condition is true, it's going to keep doing it. So it's going to keep looping through this for loop until this I is less than 10 is not true anymore.
Oh, I get it. So in this case, it's going to give me 10 chances?
Yeah.
Because it's every time I get it wrong, it's going to go up 1.
Exactly.
So, okay.
Exactly. And then the I++ just tells it, once you finish this loop, what do you want to do, right? So you can do +1, but you can also here have I equals or plus equals 2, right? So that'll get the current value of I and then increment it by 2, or
Okay.
I.
Yeah,
So that's the same thing,
Okay.
right?
But
So that'll increment it by 2. You can do increment it by 3, by however many you want, but it's most standard to increment it by 1. So if you started off at 0, then this will stop at 9. It's important to remember because if you're like iterating through an array, arrays are 0 based. So 0 through 9, it's good to know that you want to put 10 here, not 9, because then you'll go through it 8 times, not 9. Then you have the while loop, that while whatever's in here is true, it's gonna execute. So you can have a boolean in here, so you can have a condition and have it equal false, right? And you can do something, well, true. Well, your condition, there you go. So this condition is true, right? So it's going to keep doing this until this condition is false, right? So if I check to see, I don't know, if I have a temporary value here, right? And then I check if temp is equal to 10. Well, it's equal, important. 2 means comparison, 1 means assigning. So if you're doing something like this, right, you're going to check to see if the temporary value is equal to 10, then condition is equal to false, and it'll jump out of the whiles, right? And then I forgot to put a semicolon here.
Yeah, that's why it's doing when you forward.
Else, and then we increment to 10.
So temp starts at 0 because that's the initial value you gave it.
Right.
And once it gets to 10, it's going to be false.
Which means
right.
Okay, cool.
And then it'll jump out. But actually, this right here, as it stands, will create an infinite loop because every time this jumps back, it's setting temp equal to 0 again. So you want to make sure the condition or whatever's going to tell it to stop.
Are you showing the code?
Yeah.
Okay, because I'm just seeing you.
You're just seeing us? Okay.
On my monitor.
How about now?
Right.
Oh.
Alright.
Did they not see all that then?
I think they did not see all that then.
So soon
Do a break review.
Okay, so it turns out that you guys were just watching us, listening to us code. So let's just give you guys a quick review, okay? So we have the for loop, the while loop, is this right here, then the do while loop. These are the main kinds of loops that you're going to be using. And then when we're talking about the for loop, we have this one right here. This is the incremental based. This is condition based. And then what's important about the do while loop is that you're gonna do whatever's in here once, and then you're gonna check. Over here, first you check and then you go into it. So that's really the most important part about this. So let's say we set it to false. I totally misspelled false.
FAO.
Awesome. So we see out hello. Right?
You're gonna run it?
Yeah.
Already?
Well, I'm gonna
You have to comment that
this
out,
other
right?
stuff, yeah. Okay, so the do while. Oh, we have there. So ran it once, and then it didn't go through again because it was false. But if we set it to true, this is your first infinite.
What is gonna
Which is
happen?
really bad for your RAM. Well, not really bad for your RAM because it's small memory.
Holy shit. Holy crap.
You
Wait a minute, can your computer crash at one point?
Eventually,
It's gonna crash?
Eventually,
Yeah,
but I have a base level computer, so it'll take forever to use up the RAM.
Does your computer hate you?
Yeah, probably, yeah. But you can always just stop it. Anyway.
So what's going on when you're, like, you know, an infinite loop? Like, I was always confused, like, in class, like, sure, it's infinite loop, but is it storing, like, in memory?
Well,
Like, infinitely? And it's just, like, just storing it?
yeah, pretty much. So whatever you see out has to go somewhere. So it stores it in a certain part and then prints it. And then when it does another loop, it stores it somewhere else and then prints it. But it hasn't deleted the other one, right? So somewhere in your computer in RAM, you're just storing all these values of hello and printing them out, but you're not doing with anything. So eventually it'll crash.
You want to see the stats on the RAM as you run hello? So if you do Control Shift exit, I think? Yeah.
Control Shift X.
Yeah. Exit. So Control Shift exit.
There's an exit. Escape.
Escape.
Oh,
Yeah. Exit. Escape. Sorry. Like put his hands.
No. Oh, I think it went over to the other monitor. Hold on.
Yeah. Okay. And if you drag it and if you put the performance and if you do the loop on the RAM, on the thing, you'll see it. You just lost your. Okay, now if you go to your if you go to performances on top tab, it should like be selected.
Yeah. So it's doing things, but you're just printing out hello, so it's gonna be a very minimal increase. So this will slowly start to grow up. That's another way you can check. You can debug your system in case
Wait. Like if you stop the loop, we're gonna stop it, and then compare it if there's a difference. There's not a difference, but it's there.
It's because it's very small. It's negligible. But when you start working with bigger programs,
Yeah, like arrays.
you start using up a lot of space. But anyway, okay. So we got through the do while loop. Now let's check this other one.
You did the close the command prompt, right?
Oh, did I?
Did you?
Let's do this. I did.
Okay.
Good job.
Okay. All right. So there you go. Okay. So now we have the condition, the temp, and let's see it out. So see out temp,
Temp over.
Temp variable.
temp, and then there you go.
There you go.
Okay. So now
Run that loop.
wait for it to build. There you go. Boom.
You know what's going on though?
Yeah. Basically, temp started at 0, and it kept incrementing until it hit 10.
Yeah.
Okay.
And you just made it show you what number temp was at.
Yeah, but the loop.
But it didn't get to 10 because at 10 it means false, right?
Because other conditions.
Well, because we
Because
started off at
temp-
0, right? So it's important that we made this go 10 times, but really that's not important because the while it's important. It's that it kept going, it kept repeating, iterating through the loop until this condition stopped.
But if you want to increment, if you want to give the player, for example, right, 10 chances, you're gonna have to put temp equals 11, right? Not temp equals 10.
You could do another sign.
Temp equals 10 is only gonna give them 9.
Yeah. Well, if we're gonna be doing it like that,
greater than
you're gonna want to use the for loop, right?
Okay.
So the while would be more like if you're in a user environment and you're gonna be like, okay, type in -1 if you want to exit. So the while loop will constantly check if what the user inputted was -1 to exit out of the loop.
You have to do greater than inside the if statement. If you temp is greater than 10, then it's false.
Yeah. So
that
that'll
will stop at 10.
Yeah.
Now if you run it, it should stop at 10. But that means there's gonna be 11
I didn't
output.
I didn't close it. every 10. I cry every 10.
You get it done?
Yeah.
So
I
it's,
think. Yeah. Okay. Yeah. There you go.
it's another 11
Okay.
output.
Because
9.
it increases it, right? So it's just 0. It increases it once, right?
That's 0 all the time.
So when temp is equal to 10, 10 is not greater than 10. 10 is equal to 10. So it does it one more time. And then once it turns into 11, 11 is greater than 10. Then it sets this condition to false. Okay?
Cool.
So also, it's good to know that that's different than the for loop. The for loop just straight up does things that many times, right? So I can just set C out, and then just C out I.
Yeah. Then space.
I didn't close it again.
And you call yourself.
This is my biggest problem, okay? It took me like at least 2 years to figure out the problem, okay? So it started at 0 because we set it equal to 0, and it printed out the value of I, and then slowly incremented it one by one until I is no longer less than 10. So when I hits 10,
it becomes equal to 10.
It
no
be-
longer less than 10.
Exactly.
Okay,
You're learning.
So, and this is purely incremental based, right? So, in your program, you have you're doing it. You have the counter, right? You're letting the user guess how many times they're gonna. It's really could be an infinite amount of time, or they can do 3 chances. This is where you have to choose your loop, because if you only want to give them 3 chances, then a for loop is probably a good way to go. And if you want to just let them do it as many times until they get it right, then you're gonna want to go with a while loop, because a while loop isn't tied down to a number of times it can go around. But like I showed you in the beginning, you can always modify a while loop to have it work like a for loop. So just by using your variables correctly, putting them in just the right way, a while loop can work like a for loop.
right.
So let's take a look at your code. And now let's try to implement one of these loops into your code.
New message received.
That is my phone. And I hope it wasn't Kimberly. It was Kimberly. She sent me a post by I don't know who. Anyway.
You want to?
It's one couch.
Yeah. Oh, the couch forward?
Wait, at the same time as like 3 to 1. 3 to 1. Wait, what?
Okay. So
What's wrong with you?
I like to keep all my variables together, which is exactly what you do, which is great. Then
My professor likes to put them on the same line. I hate that.
yeah. Well, he does the whole
Yeah.
that thing.
I hate that. I guess it's not wrong, but I guess it's just every programmer has their own style, I suppose.
Yes, every programmer has a signature, so that would be his.
Yeah.
Okay, so we seeded the random number generator. Then we start asking, right? So
That just happens the title.
That's the title. Okay. So
Probably should comment the title.
we're gonna comment that out. I like the title. We can keep the title, but we don't want to display the title over and over again.
True.
So that's gonna be on the outside.
Oh yeah.
Right.
Yeah.
So we could shoot the title and then say, please choose a number between 1 and 10. So that's going to happen all the time.
Okay.
So then we know that our loop is going to start here. Right? So it's going to ask you for a number. It's going to put it inside your variable. It's going to check and give you a reading depending on it, whatever. And it's not going to stop until you get it right. Right? So if it's going to stop, it's going to stop right here with the one on cookie, right?
Yeah.
So right here, your loop is going to end. Okay? And if your user gets it wrong, either high or too low, then loop repeats. Right? Okay. So now we have sort of an idea of how we're going to structure our loops. Because your code's already made. If this was done from scratch, then we could have made the loop and then written our code around it. So this is a way to sort of backwards engineer a code into something new. So I personally don't like to be this, but that's fine. Okay, because this isn't. If you think about it, this is one thing.
True.
If this, else if, else this, you could really have another else. But you kind of got all your cases here, which is good.
Wait, should I have just put else at the very last one?
You could, because if it's not too high and it's not the number, then it's going to do this, right? But I mean, if you can, it really doesn't matter.
It's not wrong, but honestly.
Yeah, it's like putting all your variables in the same line,
Okay.
you know?
Whatever. It's just up to you. Okay. That's it.
Okay, so we know our loop. Let's start our loop here. So what kind of loop are we wanting here? Are we going to want it to do it only a certain amount of times until they get it right?
Until they get it right, huh?
Sure. I mean, it's already being mean. Why not torture them?
Okay. While, and then.
Hey, it's my program.
Okay. So let's just write that so we don't get an error. Okay, so our loop repeats here, so we're gonna get everything up to there and put that inside of our loop. Alright.
It's a lot cleaner now.
I'm just putting that out. So our loop ends here. So whatever condition we put in here, it needs to set false, right?
Yeah.
So let's on our variables, let's have our boolean.
Full condition.
Right, so wrong. False. Okay. This is a trick that I'm gonna teach it to you, but try to follow me here, right? So there's a not operator, right? So it'll switch whatever's in front of it to the opposite. So if you have true, it'll switch it to false. If you have false, it'll switch it to true, right? So while, sorry, let's make this correct, right? So while you're not correct, oh,
You good? Hey.
okay, there you go. Okay, so while you're not correct,
You know what the
The exclamation point?
Yeah.
That means
Yeah.
not?
yeah, that means not. That's what it's gonna invert whatever you have here.
wow.
Okay, so while it's not correct, it's gonna process all of this. And actually, I think I know what's causing that problem. We'll fix it right now. So what we're gonna do here is we're gonna set correct equal to true, right?
That's true.
So when correct is true, it's gonna not it. It's gonna be false, and it's gonna break out of this loop, right? So it's a lot of you have to keep track of it mentally, but it's a lot cleaner when you code it that way because it makes sense. Because while it's not correct, that you keep doing this,
And then once it becomes correct, it just stops.
Exactly.
Okay, yeah.
So then right here in our loop end, then all we can just say is correct equals true. And you did what you did. That's all you need to do to loop it, right? So right here we can just put a Cia. Alright, so let's try compiling it real quick and see what we got so far. Maybe we made a mistake, maybe we did. Okay. Okay. Who's this a number between 1 and 10? Kimberly! Pick a number. 6. Okay.
Wrong number.
Lol. Wrong number, boy.
What is it?
Bro.
What?
Other Sergio.
9.
9. Wrong number, boy.
3.
3. Okay, so it's not 6, it's not 9, it's not 3.
10. We keep doing above.
2.
6. Oh my god. Sure.
We already have 6.
2. Say 2.
Hey, we got it. It was 2.
You got it?
We got it. It was 2.
We got it.
Want a cookie?
One cookie. There you go.
It's if you don't know, it's a mean random number generator. So if you guess above the right answer, it tells you LOL, wrong number, boy. If you score below, if you guess below the right number, it says sucks to suck. And if you finally get it right, it asks you if you want a cookie.
Yes, I
You can't win with this machine.
There you go.
It's just always mean.
So then there you go. We have successfully implemented the.
Oh, so it actually ended as soon as.
Yeah, it actually ended.
All you
So
did was click the key and it ended.
if we were to go ahead and take out the system pause. And oh god, here we go again. So
you
5,
just
1, 2, 3, 4, 5, 6, 8, 9.
Yeah.
I love how the answer, the number was 10 when you had finished counting up to 10.
Worst case scenario, man.
Happened.
That's your big log of your big O of n is linear time.
Maybe you can wrap it around another loop that asks, do you want to keep playing?
Yes, so you can nest the loops, right? So when you nest a loop, you have a loop inside a loop.
It's like loopception.
It's loopception, man. That's exactly what it is.
Yeah.
So we just add another condition, right? So make bool keep going equals false. Right. So we're gonna put this loop inside of another loop. You do what it tells you.
I better get good at this. I feel like I'm gonna struggle.
Well, that wasn't. Keep going.
Sam.
Oh.
Read the code again. Sergio, we love the code.
Up there. There you go.
There you go.
Okay, let me fix
What do
that.
you think is causing that?
Oh, I know what's causing it. Before the stream started, I added a hotkey to the what's it called, to the changing of the scenes,
Okay.
and I set it to the keys 1 and 2. There you go. From now on, we'll just have to manually do it. Okay. So while we're not keeping going, let me just make sure that we seem to be getting errors here, so let's find where it is. So I think Visual Studio ate one of our parentheses.
8.
Yeah, I think one of the parentheses. So if you highlight this, your main, right? So theoretically, this main one right here, this brace should be this brace, right? But it's grabbing this brace instead. So let's take this out. Take this out. Take this out. There you go. Okay. So that fixed that problem. There you go. So now this brace is going with this brace, that brace is going with that. Okay. So let's just do while. go, just like that. I'm gonna grab this brace and manually put it under here. Like that. Alright. Okay. So it's gonna run this, the whole thing, and once it finishes, it's gonna ask. Alright, do you want to keep playing? Alright? So that's a good time to use our do while loop. So it's gonna go do this once, and then check if they want to keep doing it. If they want to, if they want to keep doing it, then it'll keep going. So the do goes over here. Do while true. So essentially, it's an infinite loop. It's gonna keep doing it. But right here is where we want to ask. So cout, would you like to keep going? So we can't just ask the user to give us a true or false, right? So we have to tell them what value to put in that we're going to interpret it as a yes or no, right? So it could be yes or no, or 1, 0. So let's just go with yes, no, right?
Wait, so yes or no can be anything. So you could input kitty cat for yes and
Doggy dog.
Doggy dog
For
for
no.
no.
Yeah.
You could. I love computer science. Holy shit.
As long as you're checking for it. Alright. So we're going to go back to our variables, right? And we're going to put a character, and it's going to be keep. Or what's a good name for a variable that's going to check if you want to keep going?
Get good.
Okay, get good.
Get good.
Alright, so it doesn't have a value here. We're going to add it here. So cn get good. And then we check. If get good equals whatever character, so yes, keep going. Well, actually, we check for the condition that breaks. So if they put, no, I don't want to go, then we change the keep going to false or true, because we're not even very true. Keep going. There it is. Alright, so it's going to be false. So if we say yes, keep going, it's going to stay as true, and it's going true, false, 0. Yeah, perfect. Yeah. So when we break it, and it's really great if you're using. This is where when I was telling you that you need a good IDE comes in handy, because if we run this in debug mode, you can always put a break wherever you want to check. So for example, right here, our loop starts, and you want to know exactly where your code is going. You can put a breakpoint here, and then run it in debug mode, right? So instead of Control F5, you just press regular F5, and it's going to stop your code at that point. And you can even look. So if we bring this here and this here, now you can see your code here, and it shows you all sorts of things. So even down here, it'll tell you what your random number is. So the value of your random number is 2. Let me bring this over here. So I think we are going to be right here today. Awesome. So then you can step it forward, one step at a time. So C++ and the compiler works by getting one command at a time and then going through it.
And so I can tell it, okay, run the next line, run the next line.
Exactly. So you can step over.
Do it. I did not know that.
So it just ran where we stopped. So if we do the step over again, which is F10 here, it's going to go into the do. So it didn't check. It just went straight into. And now it's going to do the whole. Please, that's a number between 1 and 10. right?
Yeah.
So now it's going to ask me to guess a number between 1 and 10. And thanks to the debugger, I know that the number is 2. I got it right. So now it's actually going to check what number did I put, and it goes into that part instead of keep going. It goes into here because it knows that we know.
Did not know that.
So now it's asking us, would you like to keep going? That means that it is at this point now.
Nah, dude.
So right here, say, no, we would not like to keep going. We send that value back, and it stops. Right? So it continued. So our loops are working great. So that's what the debugger is for. So you can follow your code, check all of your variables as you go. So it'll list all your variables here, so you don't have to worry about, oh man, what variable does this have? All your local variables, here they are. So it actually shows you even the ones that aren't initialized. So, for example, get good. We just declared it. We didn't initialize it. And that's very important to know because that might be on your CS1 test. What's the difference between declaring a variable and initializing a variable?
Initializing assigns it a value right off the bat. Not initializing it, or just declaring it, leaves it without a value, and you're probably going to let the user give it a value.
Exactly.
Yeah, cool.
That's exactly correct.
Okay.
And that took me like a couple semesters to figure out. So you can keep track of all these things. So if you get down and you're like, well, why is my program acting all wonky? How come it won't go into this specific part of the if statement? Well, you can stop the program right before it gives it a value, and then check. Oh well, if you usually have some big number like negative, whatever that is. Hold on, that's not a normal number. It usually has garbage in it before. So if you don't give it a number, it has garbage in it. So that would be garbage. Just like get good is like negative 52i. Right? So your debugger is very important. So that we have successfully implemented a while loop, a do loop, and I think the only thing we haven't implemented is a for loop. So a for loop, yeah. So let's switch this up. Let's keep the while loop on outside, but let's only give it let's only use a for loop in the inside. So if we remove the while loop from the inside, what's this one? So we're replacing that while loop with a for, and I equals 0, I is less than 3. So let's say it's a video game and you only have 3 tries.
Lives.
3 lives.
3 lives.
There you go. Let me just build to make sure. Oh yeah. So I'm still debugging. You want to stop debugging, build it. Let's try it again. There we go. Succeeded. So we're good. So our for loop is working. So it'll be here, right? Yeah. So it's gonna do this 3 times. So what happens? You have to think. What happens if we're on our second life and we get the number right? Then it's gonna keep going.
You get a lot.
So we have to find a way to break out of the loop if you finish before you run out of lives, right? So wherever we have the same condition, where we want to exit the loop, we literally just type break, and that'll break out of the loop. So since we want to speed through this, we go into our debugger, and step over. Just continue it. There we go. It's a number, and our number is. I guess it continued it, so it didn't keep the value. So I guess we're gonna try 3 times.
3.
We have 3 tries.
3.
2.
3.
1 more try.
9.
Aw.
Wait. So, but it's
So do you want to keep going? Yes.
Oh.
Okay, so now we have a different number though.
6.
Or do we?
Try 2.
4.
Okay, so
I'm gonna punch a computer
Mike.
if it keeps insulting me.
so actually, since the random number is outside of the loop, every time it comes back, it doesn't set a number 1. So we were actually just
Looking for
Let's
the
look
looking for the same number
We
over
could have
and
just
over again.
gone 1 through 10. Just probably got it.
I got it, yeah. Let's try this. Let me take out that breakpoint because I don't need it. Oh, it's already gone. Okay, so what we needed is right here. So the random number is 2. It keeps being 2.
It could be. No.
So
It's
10.
random.
So number original 1 plus is going to be 2. And F10. Okay, and then right here, we got it right. So this as soon as we step over this, it should break out of the loop and ask us if we want to play again. Would you like to play
Yeah.
again? There you go.
Hey, so like when I'm playing Call of Duty and I'm playing Search and Destroy, which you only have 1 life.
Okay.
Is that, do the programmers that make Call of Duty use a loop to determine, to give you only 1 life? Because in team deathmatch, I can just die as many times as I want and I'll come right back.
Yeah.
Search and Destroy, I'll only get 1 life. So do they use these kind of things?
So what they would have there, I would think they have a condition statement, right? So if you're playing Search and Destroy, then when you die, it's gonna check what game mode are you playing. Well, if you're playing Deathmatch, then just respawn and keep playing. If you're playing Search and Destroy, then switch spectator mode, right?
Oh, I see.
So let's go. But if you're playing in like what game would you have lives in? Like Pac-Man, right? Then you have I would actually think Pac-Man might be was made on a for loop because every time you die, it plays the every single time when you die.
You got it right too.
So that's probably on a for loop. You have 3 lives, right? And every time you get a new life, that counter you just set it down 1. So that means it's gonna go through the loop once more, right? So every time you up a life, technically you're going down in the counter, so it can go through it again, right? Follow me?
Yeah.
Because if you're iterating through your 3 lives and you're on life 2 and you pick up another life, then you give it another life. Anyway, so
You might want to be able to install those classes because you only have 12 minutes.
okay, so that should sum up your loops. Everything else is.
I
very
have
simple.
one question.
Okay.
Something that I noticed earlier today while I was trying this out. While I was trying out my program out.
Okay, go for it.
I noticed that it did this one thing. Can we revert it back to the way my original code?
It should. Oh God.
I guess you could just do
Oh wait, didn't you? You commented it out, didn't you?
No, I started working on it.
Oh, and then you saved it? Every time you compile it?
It saves over it, but you made a copy of it when you moved it into my computer. So the original one should still be here. Where did you have it saved?
Comski?
Comski.
Sorry.
Copside.
Hey, whatever. I don't give a shit.
Mean Machine.
Mean Machine.
Okay. So here we go. So.
Is that how it was? Yeah, that's actually. Oh no, it's not.
Wait, no, it has a loop.
It's
so,
okay.
So yeah, it saved over it.
It's okay.
so tiny.
Let me try something out.
Go for it.
Okay. So then.
I mean, we really didn't change much. We just added a loop.
Just delete these. Okay, that was there, and
Here.
No, hold up.
Okay.
I think I got it. So, if username that, else if. Okay, so now I just have to delete these. Delete that. Alright, and then. Alright, do you have a picture of how? I just need to know what the first part was.
You're
No, remember
pretty much
Facebook, right? Facebook. Oh, here it is. Yeah, like that. Sorry, no, it's
There you go.
this actually really intrigued me today. No, because now it doesn't have the condition. Oh wait, does it?
There wasn't a condition when you did it. Yours would just run once.
Oh, so if username equals to the number. Okay, cool. So can we build it without debugging, just regular mode? Random number is 3. Guess the number. Okay, so if you guess. Here are the conditions. So if you guess it right, it asks if you want a cookie.
Mm-hmm.
If you guess above, if your number that you guess is greater than the real number, than the actual number, it says LOL wrong number boy. And if the number you guessed is less than the actual number, it tells you sucks it suck.
Mm-hmm.
So here we see that our random number is 3. So if I put a number less than it, it's going to tell me sucks to suck. Control F. I can just open that again. I should have left that one to then. Alright, and now if I guess, so the number was 3, and I guessed a number less than it, which was, I believe I entered 1.
Yeah.
Yeah, and so it's only sucks to suck, right?
Right.
Okay, and if I guess above, if I guess above the number, our number is 10, so if I put 11, wrong number boy, right?
Mm-hmm.
So that number is above it, right? It's greater than that number.
Mm-hmm.
Do it one more time. However, if I were to just, here the random number is 1, right?
Mm-hmm.
If I do something like that, sucks to suck. How is this number less than 1?
Okay.
What the hell?
So
I was like, why are you giving me that? It's supposed to be above. You're supposed to be telling me, oh, wrong number, boy.
an integer can only have
I think
a set value.
Yeah.
Right?
Oh, yeah.
So you have a max number that you can fit in a
Would you like 2, 5, 6, something?
yeah, it's somewhere in
Somewhere in the billions, I think? Like 2 billion, I believe is the
we can.
I was doing my homework and it said, I remember it saying something like that.
Max and alright, so it's that.
That number, that's...
Yeah, so if you go above that, what it actually does is it just resets it. Because in binary, once you add 1 to like that big number, it's just gonna come back to 0.
So that past 4 bits. Or
So
more.
if we have this, right?
More than 4 bits. How many bits is that?
Alright. And this was actually one of my first homeworks with Dr. Wiley. Okay. So we have an integer x, right?
Yeah.
And you have a value of that. And then we print it out, see out x. But then we increment it by 1. And then we print it out again. It failed. Where did we fail? Oh. Okay. So let's build it.
reverted back to
It went over to
the
negative.
lowest number that it could possibly be.
Exactly.
Okay.
So if we were to add 1 to that, now that goes. If you think of it as like a number line, right?
No.
So it's gonna jump all the way to the lowest number it can, and then go up by 1, 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 up by 1. Right. So it's still lower. So and then it's gonna jump again. So
Okay.
it does this little loop.
So that's why it was giving. That's why it was giving me the response for a number less than when to me it looked like a number above.
Exactly.
Okay.
Because you were giving it a number that was way too big. When it tried to assign it, it couldn't.
Okay.
It would loop back around.
Okay, cool. Yeah, because today that just intrigued me. I was just messing with it, so I'm like, fuck it, I'm just gonna hold my finger down. See what it gives me. Alright, yeah.
Okay, so
Cool.
let's do a quick introduction to classes since we're running a little short on time. I'm gonna go ahead and delete. Actually, no, let's not delete your code. Let's just start a new one. Yeah. Item. C++. So it's yours. I'm gonna just close it. Remove. There we go. So now over here, include. It's hashtag.
And also stream. Also stream. You forgot an E.
Look at it.
Okay, and then int main there we go. Okay, so a class is we have a visitor. Okay. So a class is, you can think of it as an object, right? So when you create a new class, it's pretty much a set of variables that are all related to each other, right? So if you have a car, right?
Yeah.
Well, a car has a make, it has a model, it has, a size wheels. It has all these things. You have some people give it names.
So a group of Fiats would be one class.
A car would be a class. A Fiat would be what you initialize that class to be.
Okay, so a 500 would be a class because it's a Fiat 500.
So you would have a car, and that would be your class. Fiat would be the values inside the car.
Okay.
You could have a class, name it Fiat, and then put in all the values, and then just have a bunch of Fiats, right? But usually you want to keep it general, right? So let's show you here. So if you have a class, car, right, and I think that's it, and then semicolon. So, this is gonna sound really funny, but I promise it doesn't mean what you think it means. In C++, your classes have public parts and they have private parts, right?
You said like that on purpose.
Private parts are only accessible to the class itself, right? So a class can only grab its own private parts.
It's true though.
It's so true. Like that's exactly what it means, right? So if I have a variable named name, right? No one else can come in and
touch my private parts.
Exactly.
You should make a program and say we're 5 years old because you probably are.
So you name private and public.
Shouldn't you put the private first and then public?
It doesn't matter when you write it like this.
Really?
It automatically knows, right? So it knows that whatever comes after it is going to be public, and whatever comes after it is private. So you don't have to have public. You don't have to declare the private, right? Because a class by default, everything inside of it will be private. right? So you can let it know, hey, I'm gonna have public parts, and anybody can access these, and then it'll tell it okay. But if I leave it just like that and start put, I don't know, string name, right? Oh, let me include the string library. There we go. Then when I try to make a new car and grab the name string, it's not going to let it because it's default as a private. But if I do public, then it's going to say, okay, then over here I'll be able to grab the name from the car, right? So you're going to have what? Make,
so why do we do that, Phil?
model, and what else do cards have? A make, model, and year, right?
Year.
So year would be an integer. Right? And let's make all of these private parts.
Because we don't want to touch that, right? Like
yeah, so
you
one
explain what the private is.
By not touching, you mean you wanted to leave it like constant?
it means that no once you declare it out in the main program, which is done here, the only thing that can change these values are this class itself. So if I have a function that says change the name, right? Only that function can change the name. I can't go in here and say like car fiat name equals new or equals Isaac, right? I can't do that because I would have to say fiat dot change name and then give it a value that I wanted to change to, and it'll reference that function up here and then have that function do it for me. I can't directly change that value. So we have here. There we go. So like I was saying, let's create a void function, right name, change, or set, make.
I forgot about void. Yeah, that's it.
String
You know what void means?
it's empty.
No,
It's like the real, like the actual definition of void, or
you know why they use it for here.
No.
So void function basically, you know how like a function was like int to return something as an integer, like
Yeah.
int like to return x and x is a number. Void basically means you're not returning a single thing. It just does it. It does it. It's gonna change something or do something. You know, it can still print stuff. It can still do math. It can still do calculations for you, but you won't get something from that function. So let's say at the int main, I wanna do cout show x, but if the function show x is a void, I'll get an error, right?
Mm-hmm.
If the function show x is an integer function, then the program will grab like what that return value of that function is, and it like gets it and it spits it out to the user. So it's just grabbing and setting the grabbers, I guess.
Okay. So, like I said, this would be the setup, right? So we have functions, we have variables, right? And usually you want to keep your variables in your private part because you don't want the rest of your program to mess with it, right? Because that's gonna mess. If you have a car and all of a sudden you have, let's say you have a Ford F-150, right? You don't want to have like a random Chevy F-150. Right, you want to make sure that only this card will handle how it changes its information. But you can have this card change the information if you want, and that's what these are. So I made these three functions that'll go in and change this information, right? So they all essentially look the same, like this. So I have a function, set, make, and I give it a string, and I just go in and I make equal to whatever string, right? Another thing is, if the function you create, you get to do this once. You can create a function that's named exactly like the class, and it'll automatically. It's called a constructor, and it'll create that class, or an object of that class,
It's like a default.
with these values in mind, right?
It's like a default of a car.
Yeah, it's how your class will default. But you can also just have car empty and make equal null, mono equal null, and
blank.
here equals null as well.
So
It's
Oh,
null
cast.
cast, yeah.
yeah, so like if you were to print that out, it would give you a strange number. Like it's a different number like every time. Because null is actually pointing at nothing, right?
Yeah.
Yeah, like null it's like a random pointer like in RAM. Like it's just like
So it's pointing in your random direction.
yeah, and then like if it's pointing over here and like if that number is like 661,
666.
I'll give 6666, yeah. And like if you print that number out, it's 661. But it's always moving. So every time you run that program again, it's gonna show different numbers because it's always pointing at weird stuff. Because the computer's always moving, right? So that's a cool thing about null. Null is also really good to let you know when something is ending or empty,
Okay.
which we'll do that later. I think
this
it's
is
which is CS2.
Okay. So this would be how you would set up your class, right? So essentially you have a class that has some variables that all relate to each other, like a car, as this, right? You have a constructor that if you create it and you don't give it anything, it'll just set some default values, or if you give it some predetermined set of data, it'll set the data to that, right? So this is just a quick overview onto how the classes will work, and during our next podcast, we'll go into a little deeper detail over that.
Yes.
That
Yeah.
way, because a lot of programming languages nowadays are very object oriented. So you can think of this as an object, right? So your car is your object, and every time you make a class, you're making a new object. So this is very important to get a good grip on. So we're going to go ahead and cover it a little bit more detail next podcast.
Well, thanks. I'm kind of the cool kid in my
In your
my
class
CS
now,
class.
you just show up and you already know everything. Like, yeah, I know what a while loop is.
Yeah, some kid's just like staring at his my husband's like staring at his monitor dead for like 20 minutes. Hey man, are you getting it?
Just take over and do it for him.
Just like
You
flip the
put the
monitor
computer.
over. There you go. Stop wasting my time.
Yes. All right. Well,
We'll sign out here.
we're gonna go ahead and sign out for the day. Happy Valentine's Day.
Hi, Van.
If you're watching us, then you're probably coding, and we wish you a happy Valentine's
Or
Day.
so you're watching our stream like with a couple.
Or if you're doing your homework and
Yeah, soon.
you have priorities and so you don't have someone to spend Valentine's Day with, we're glad you're spending it with us. Like us, subscribe, and follow us on our Patreon to help these videos keep coming. Yeah, it really helps out, so we can get better equipment to bring you guys the best possible quality you can. Also, if you back us, there's certain rewards that we can give you guys. So if you're having trouble with your homework, just go ahead and back us on Patreon, and we can actually give you live feedback when we're gonna have whenever we start the podcast on the next episode. So it's a great deal for you guys, and it's a great deal for us, so we can help us help you.
It's a win-win, if I say so myself.
So without further ado, thank you guys for joining us, and that was the next episode of the podcast.
Thanks a lot.
Ciao.